Thanks for joining, everyone. Week 2. Today we got something special. It is a special topic, in fact, with Howard Baek. He's going to be talking about gganimate, which is a R studio package that allows you to animate real-time graphics within your R studio space. So he has a full presentation and a demo to go through. So with that, thank you, Howard, for being here, and I will let you take it away.
Okay, thank you, Nick. Can everybody see my slides here?
I can see them.
Yep. Okay, great. So hello, everybody. My name is Howard, and I'll be talking about animating expected position value in the NBA with gganimate. So agenda for tonight is introduction to expected possession value. I'll be giving a background behind this project, talk about the source of the data set, and then describe what expected possession value EPV is, and also show you the original prototype of the animation that I improved upon with gganimate, and also give you an intro to gganimate. And then after that, I'll be walking through my R code that I used to produce these EPV animations. And while I'm walking through the R code, I'll try to pause between every step so I can give you time to digest the code and ask me questions. And then lastly, I just want to give you some resources for you to look at in the future. And also, I'll be sharing the links to these slides, which are online, so you can look at these. Okay, let's get started. So I came across this MIT conference short paper by researchers at Harvard. This paper contained interesting title, and it contained words like predicting real-time and NBA optical tracking data. So I read this paper and I found the statistical theory behind EPV was too advanced for me to understand the model. These were made by PhD and researchers in statistics, so I didn't have that training. But fortunately, the authors shared the R code and the data set behind the animation or their paper. It was shared on GitHub. So by using the R code on GitHub, it allowed me to reproduce the results in their paper without having to understand the nitty-gritty of the model, and thus started my whole project. This is talking about where the data sets come from. It's from an NBA optical tracking system called StatSportView, where the NBA installed 6 cameras in every arena, which these cameras tracks the 2D locations of every player and also the 3D coordinates of the ball. So you can see here all 6 cameras here. So these cameras record data points 25 times a second and 72,000 times a game. And that amounts to about 1 billion times a season. Feel free to stop me if you have any questions too.
So right off the bat, actually.
Yeah.
So on the last slide, I know it was just the video, but is there any logic why they have 2 slightly different angles on the same side of the court for on the bottom left and the bottom right video?
Oh, this one and this one?
Yeah, what was the logic behind tracking the 2D location by using those 2 slightly different angles?
I'm not a computer vision expert, but I'm guessing that it has something to do with um, the angles of the camera. They help the computer vision like detect, because I'm guessing they use computer vision to track down the X and Y coordinates.
I was just wondering if the paper maybe mentioned anything about that. Okay.
Oh,
No worries.
no, they didn't really. Okay, so expected position value is a multi-resolution model. So that means there are two layers to this model. There's a macro transition and a micro transition model. And both these transition types account for the discrete and the continuous nature of the sport of basketball. So macro transitions are they refer to passes, shots, and turnovers. And then micro transitions refer to every other movement that the players make the ball. So EPV is calculated using this formula here, where it's like your normal expected value formula, where you multiply the average of the macro transition, the average of the points from macro transition times the probability, and then you add that to the micro transitions. So it's basically a weighted probability average. So like I said, the authors wrote another theory paper here, and if you want to learn more about this, you can read the paper. So in that in the pointwise paper, the original paper that I referred to, the authors made this graphic here. It contains the action on the court on top, and then it has this corresponding EPV curve here. I thought this is a static graph. It's a bit boring because it's not moving at all, and it also requires effort by the readers to understand really what's going on. So with the recent development of gganimate, I thought that I could spice this image up, and I created this imager or this animation, which is a lot easier to understand and attention grabbing. So since there is movement, it grabs your attention, and also requires really minimal effort to see what's going on. It's pretty obvious that right over here is the action on the court, and the EPV curve here moving simultaneously with the curve. I mean, with the action. The way the EPV works is the authors calculate EPV starting from the time the ball crossed the half court. So that's why you don't see EPV around this time, but then around here you start seeing the EPV popping up. So what is this gganimate R package that I used? Well, it is an extension of ggplot, which is also another R package that is used for plotting. So while ggplot2 is based on a grammar of graphics, gganimate aims to do the same with a grammar of animations. So what the author of this package wants to do is he wants users to feel very. He wants basically to make it very easy to create an animation, gganimate animation with ggplot. So once you have a ggplot object, you just want to add on a couple more lines of gganimate, and you'll get a simple animation like this. So there are a few functions right now. I think the major function here is the transition family functions. These are the workhorses of gganimate, and it defines how the animation should be created. So this is the major function, and we have some secondary functions to kind of change the way the animation is like viewed. So view is one of those. Shadow is like kind of adding a shadow. Enter and exit controls how the animation, how the graph enters the animation and exits the animation. And then, okay, now I want to go through my R code, which is, okay. So I load these packages here, the tidyverse, gganimate, rvest, which are used for scraping data off the web, magic for image processing, ggRepel. So the raw data set contains the time column, the time variable, which is the real time in seconds. The XYZ column is for the position of the ball, the 3D position. The game clock, which is the time remaining in each quarter. And then we have these H1 to H5 ENT, which stands for the player ID of the home player, number 1, all the way to number 5. And then away player, number 1 to 5. And I found this website, swishanalytics.com. And I used this website to scrape the jersey numbers of each player by using the player ID to scrape the jersey numbers. And then EPV.smooth is the EPV metric that I've been talking about. Okay, so in this R code demo, I just want to go through step by step, on how I made the animation over here. So I'm going to start off with this bottom animation. So first I needed the NBA official court. And I got this with this function here that I stole off somebody's webpage. So basically all this ggplot code allows you to load this package. It allows you to plot this NBA court in ggplot. So once I have this, I also wrote this grab jersey function, which uses the rvest library that I mentioned over here to scrape the jersey numbers off this Swish Analytics website. So that's the function. And the next step is that now that I've made the NBA court, I can add on points to the court with the geom_point function. So these points are going to represent all 10 players on the court and the ball. So I'm just going to look at one position here. And this code here is just going to plot the movement of the ball. And all these geom_point functions plot each player. So home player number 1 all the way to 5. And then away player number 1 all the way to number 5. And then I believe this is the ball. So here is the very first animation that I made. So the way I made that animation is, like I said, gganimate is just an extension on ggplot2. So all of this highlighted part is ggplot2 code. And then I just added on a couple lines of gganimate. So the transition time, it just like tells gganimate to create the animation using this game clock variable. And then this gg title here, it uses the game clock variable to like show the time in the animation. So this is like a very crude version of the animation. You can't see the jersey numbers here, and the dots are pretty small. So I will now incorporate the jersey numbers by using the grab jersey function. And then I scrape the jersey numbers here. I get all 10 players' numbers, and then add it on to the data set. And I use this geom_text function to overlay the jersey number on the dots. So you can see here, we see, this is LeBron James. You see number 6 overlaid on top of the dot here. And one little trick that I learned is ggplot, it makes the graph like in the order of your function. So if you basically plot the text and then the point, then what the plot is going to look like is just the dots without the jersey numbers, because ggplot is gonna make the text, or it's gonna plot the jersey numbers, and then on top of that, plot these little dots here. So I had to write the geom point function and then geom text to show these jersey numbers. Does anybody have any questions so far?
Did you slow the animation down slightly from the first iteration?
From first iteration? Yeah, I believe I did. So I think that these are all GIFs, but when I rendered the animation, I think I also changed the animation speed, because I thought this one is a bit too fast.
Yeah, that looks good.
Thanks. Also, one other change that I have is I think I added this thing, little thing here to make this game clock more realistic. And speaking of game clock, I wanted to copy this NBA broadcast game clock, where the broadcast screen, they always have this like quarter thing next to the clock. So that's what I did. I've changed these data values from the numbers to first, second, third, and fourth. Then I went on to make this animation here. So now you can see the quarter added on to the clock. Yeah, Nick, just going back to your question, I think I changed the animation speed with this parameter, frames per second.
Got it. Okay. And that just, if you have the same total number of frames, it will just take longer in total, right?
Yeah. Okay. So now we've got this part here. You just gotta plot these curves here, which are a lot simpler. They're just like a regular, like a line graph, kind of like a stock graph. So you just gotta make that animated. So I look at the second position here. And then here, this time I use transition reveal, and transition reveal here allows me to like gradually build up the animation instead of transition time. So what the final product is like, it looks like this. So like I said, transition reveal allows the lines to gradually be built up, and then the way, and what that means is it knows to only keep the old data. Whereas I believe transition time, which I use for my court animation, it does not do that. So if I use transition time, I don't think transition time will allow me to like keep all these old data in the animation. All right, so now that I have these two separate animations, I used the magic package here to do some image processing. So combine these two things. So basically I saved these two different GIFs in an object. And then using the magic package image_read, I read these GIFs. And then I think what this does here is we basically combine these GIFs frame by frame into one like big picture. And then I use this for loop to do that. And the final result should be something like this, where these two separate animations are combined into one. All right, does anybody have any questions about the code that I have here? Okay, if not, I also want to show you this web application I built, again using R. So this is called a Shiny app, and it allows you, so it was built using the Shiny R package, and it's kind of like a simple web app where as a coach, analyst, or like even a player, you can look at each individual possession, assuming that you know what position you want to look for. And you click on the possession, and the app reacts to your input and shows you a whole new animation. So gganimate is a package that is fairly new. It's very in its early stages. So right now, I don't think it is possible. Well, the rendering time is very slow. It takes a few minutes to render each animation, unlike ggplot, which is instant. So I think in the future, when gganimate's rendering speed catches up to ggplot, I want to make an app so that somebody can just like click on any position and see this position right away by having this app make all the animation in the back end. Because right now for this app here, I had to preload like 100 animations that I have on my local computer into the app, which is takes a lot more time. Okay, so just to top it off, I've included a resources page here, which has the original R code that the authors provided in their paper. Pointwise is it's the article that originally caught my attention. This thing is a YouTube video by the authors of the paper. This one is that theoretical paper that contains all the theoretical statistics behind the model. And then if you want to learn more about gganimate, there's a lot more resources, but I also have this link here if you want to look. Yeah, thank you for listening to my very short animation presentation.
Awesome. Howard, thank you. So if we wanted to like access these resources or see your Shiny app or like dive into the code, where would we need to go to do that?
Yeah, I was thinking of like putting all these links in the chat here on this Zoom here, but I couldn't find the chat function here. So
That might be
if
something.
you could like enable the chat or something,
Yeah.
then I could like share all these links.
I know how to do that. I will do it.
Okay. Meanwhile, if anybody here has any questions, feel free to unmute and ask me questions, because we still have like 10 minutes, 10 or 20 more minutes.
Not all at once, please.
Sorry?
Oh, I was just making a joke.
Hey, Howard. I
Hey,
might have
Nick.
missed at the beginning, but I was just wondering what your background is. I see you have at UW address, but I was just wondering if you're like studying anything right now.
Yeah, I'm a junior majoring in statistics.
Okay, gotcha.
Yeah.
Very cool. Is that undergrad, right?
Yeah, I'm an undergrad. That's why I said originally that like the statistics behind this is like very advanced. I think you need at least a master's degree to understand this,
Mm-hmm.
the model. So that's why I really appreciated the authors sharing their R code. That just made it a lot easier for me to like reproduce their results,
Right.
without
Okay.
having to know the theory behind it.
Gotcha.
Oh, hi, Howard.
Hey.
Can you explain again, how did you transition from frame to frame? Is it using the transition function?
Yeah. Do you want me to go back to the code?
Yeah, thank you.
Are you talking about the EPV curve or the?
Like both. How did you like make it animate? Like how did you switch from frame to frame?
Oh yeah, yeah. So like I said, gganimate is an extension on ggplot. So Alan, do you know what ggplot is?
Oh yes, I've used it before.
Okay, great. So do you want me to just walk you through the code again?
Yeah, sure, thanks.
Yeah. So all of this here, all of this highlighted code here is just ggplot2 code.
Yep.
So this is just gonna be a static ggplot. And it's just gonna show you like the paths of all the players. But this gganimate code, this function, transition time, that's what's telling R to like make the animation. And it's this is like a variable in the data set. So we are creating an animation frame by frame on this this game clock variable. So this game clock variable is like in seconds. So like the animation is, yeah, it's based on this variable here.
Oh, okay, I see. So it's like the data has like at each second, they have the position of each player and the ball. Is that correct?
Yes. Yeah.
Okay.
Yeah. Well, we have, because each row in the data, I guess if I showed you the raw data, would that help your understanding?
Yeah. Thank you.
I shall look for the raw data.
Did you also wet scrape the sports view data?
Sorry, did I web scrape the
sports view data, or did you?
Oh.
Is it? Oh, yeah.
So, so this paper or this GitHub repo here contains the data folder.
Oh, I see.
So they shared like a small sample. Right? Just like here, I'll show you what they shared.
Okay.
They have this. So this one is the raw data. You can also access this on GitHub.
Okay.
So it's a one game sample. Takes a long time to load. Okay, here you go. So, like I said, the sport view cameras record 25 times a second. So, so like this is the game clock variable. So you can see like there's data for like every 0.04 second. And then the X, Y, and Z coordinates of the ball. And then all these columns here are the locations on the court for each player.
Oh, okay. Yep, I understand now. Thanks.
Okay, no problem.
Hi, Howard. I have a question.
Yeah, Jonathan.
So you mentioned that like one of the limiting factors for gganimate was that it's not very fast to render, like the animation.
Yeah.
That sort of like limits you to only be able to do like 1 second each time. Like you can only look at the frame 1 second at a time, or that's what you have in your code. So I'm wondering, like, once they sort of improve the render times for the animation, like, what would you like look at more, like closer frames, so like you could have see more frames and like the animation be smoother, or like do you have certain goals for that?
Oh, yeah. So I think when I said rendering time, I think I meant like right now it takes a couple of minutes just to render each of these animations.
Mm-hmm.
So if you want to make like, where is this thing? If you want to make this from our studio, it's gonna take like a couple of minutes just to like create this whole thing. But in terms of like frames, I think that depends more on your raw data. So if you want a more like granular and like a more smoother animation, then you want to have like, I guess, more data, so
Right.
that, yeah. Does that answer your question?
Yeah, that does. It's just that like for your what you've done, you've only looked at each second, so technically there's a lot of data that you didn't include in the animation, but
Oh, so I think what I failed to mention in my presentation is that the data that I use is, so each row, so I guess I'm trying to say each row is 0.04 seconds. So it's more granular than like 1 second.
right.
Does that make sense?
Yeah, that does make sense.
Yeah. So in my opinion, I think this is pretty, like this thing here is pretty smooth. But I think in terms of like EPV, I know that in the theoretical paper, the authors mentioned that they had to kind of like apply a smoothing algorithm to the EPV. That is why they call the EPV.smooth. So before they just had like a raw EPV that was a lot more like crooked than the smooth EPV curve you see here.
That makes sense. Thank you.
Yeah.
So to update everyone on the chat fiasco, UW actually disabled chats along with whiteboards and other annotations because there were people coming into chat rooms that weren't theirs and doing some explicit thing. I've enabled it, so for starting next week, there's a way to like manually enable it. So the next time I start this meeting room, we'll have that functionality again. But by default, it was disabled. So.
Wait, so you said you've enabled this chat?
I have, but I'd have to restart the meeting in order to enable it.
Oh, okay.
It's not going to work until I could stop the meeting and restart it, but I guess another way we could do it is just if you want to drop the links into the event on Facebook.
Oh yeah.
We could just do that, and then I can redirect everyone there in an email next week.
Yeah, okay. I'll drop a link of this presentation and probably my GitHub too. So I guess the link to all this code here.
Awesome.
Yeah.
Yeah, your GitHub would be perfect, I think, because like the first time I was going through this stuff, that was like my primary resource, honestly. I was going through,
Oh, really?
yeah, I was just downloading things and
Okay.
trying to understand. It's helpful because you have all these, you have a lot of comments throughout it, so that helps understand it. Helps me understand it most.
Yeah, I try to put a lot of comments here because like I have really bad memory. And so once I come back to this, I'm pretty sure I was gonna forget about everything. So like I wrote this code like about a year ago. And so I'm like really glad I put all these comments here to understand what I did. Or else like I'd have to like relearn this whole thing again.
Yeah, well, we couldn't tell if you were forgetting anything. We did not notice it.
Really? Thanks.
Just in general, how long did this take you?
I think it took me about couple of weeks to make. Well, I did copy a lot of stuff, so I did copy the code here. I copied well, basically like I didn't have to make the model. I already had this raw data set to look at. But what I did is just like make the animation. Yeah. And also like, if you think my presentation sucked, you could just read my blog post. I think I'm a better writer than a speaker. So I think writing this blog post took a lot of time too. So Nick, maybe I'll attach the link to this blog post too.
Okay, please, yeah.
Yeah.
This is great. Oh yeah, everyone, definitely take a look at Howard's blog. It's pretty
Thank you.
inside the tidyverse.
Yeah.
Very cool.
Yeah.
It's kind of a bummer because I was looking into the sports view, that company. And
Yeah.
I'm not sure if they went defunct. It looks like they privatized the data starting in like 2011 or something, or 14 or something.
I think the NBA, they changed the company.
Oh, is that what happened?
So yeah, they're not providing the data anymore. This other company called like Second Spectrum.
Huh.
Yeah.
And they're
They're the
not
ones. Yeah, they're not.
selfish.
I think they still provide it to like researchers, but maybe they have like an NDA or something that doesn't allow them to like open source the data.
Huh.
Yeah.
Someday.
Yeah.
How did you, so that full court graphic, is that a package that you found, or is that just like an image that you put on behind? Or I guess you had to generate it, huh?
This one here. This.
Yeah, the background part though. Yeah, that.
Yeah, I just got it off this guy.
Oh, cool. Okay, but then it draws the lines and everything in R. Howard? I think we might have lost him.
So I just copied it off him.
Very cool.
I had a quick question. Did you know for the EPV metric, if it takes into account each player's individual stats? So like if you were to have Steph Curry versus a center, for example, at the 3-point line with the ball, does the EPV metric change based on that?
Yeah, that's a great question. So the authors, they actually answered the same question that you had
Mm-hmm.
in this talk that I can show you. What's this one? No, not this one. Yeah, this talk here.
Okay.
They mentioned that, but I think they said something like they use the spatial average something to like account for the different players. So they talk about like if Dwight Howard shot a 3-pointer,
Right.
like what's the chance of that going in versus like a Stephen Curry or Klay Thompson.
Mm-hmm.
And I think they say like in like the entire season, Dwight Howard completed 1 out of 1 3-pointers.
Right.
So they like said, oh, he's like 100% 3-point shooter. But that is just complete misinformation because sample size is only 1
Right.
for Dwight Howard. So I think they do account for this difference in their model.
Okay.
Yeah. So I
Gotcha.
encourage you to watch this presentation, which is really cool.
All right. Cool. Thank you.
Yeah.
Awesome. Any other questions? Sweet. Howard, do you have anything else?
If you have any follow-up questions, you can feel free to like send me an email and I'll try to help you out. And thanks for listening to this presentation. And yeah, hope you found this useful. And I guess like the main motivation behind this is to like show you like how cool gganimate is. And I encourage you to like check out this package and like make animations yourself. So thank you.
Howard, thank you so much for showing us this. And I mean, there's a lot of work that went in behind this that we obviously didn't see. The 2 weeks that you answered a few minutes ago, that's
Yeah.
part of the bigger picture. I mean, there's the blog, there's the studies, like there's a lot going into this initiative, I would say, of kind of like making gganimate more prevalent, kind of raise its awareness a little bit. And so thank you for coming and doing that.
My pleasure.
And the other thing with gganimate is like you're not restricted to basketball videos. Like you can do a bunch of different things. Like the line chart, that was one example. Another cool one that I've seen is like the scatter plot. So if you guys have seen that, Hans Rosling, he does like the growth of GDP of different nations over time and how they like just change year to year. So the x-axis is year and then the y-axis is relative GDP. And you can animate, what is it called? A bubble chart.
Yeah.
To change in size over time to see the relative size of GDPs for different nations. That's another cool example I've seen of something you can do with gganimate. But yeah, go forth and make some cool things. Okay. So for next week, we have our first workshop of the quarter. Going to be led by Jessica, Kayla, and Alan. Kayla and Alan are on the call. And what we're going to do is a little bit different. We're going to pre-record most of it, but then we're going to have a live session where we're able to answer questions and help you with any code that you want to maybe try out during the workshop itself. So look out for that. That'll be at 6 o'clock next Wednesday, same meeting room. Look forward to seeing you guys there. Thank you all for tuning in, and enjoy the rest of your week. And once again, Howard, thank you so much. If everyone is like comfortable undoing their microphone and like clapping, please do so. Or, yep, that's perfect too.
Thank you.
That didn't work. It muted everyone, but sweet. Yeah. So with that, everyone enjoy the rest of your weekend or week. See you, Howard. Talk to you soon.
See you, Nick. Stay safe.
For sure. You too, man. All right, guys, I'm going to end the meeting here. So if you have any questions, shoot us an email offline. And officers, if you guys want to talk via Slack, we can do that too. All right, thanks everybody.